triangles are congruent. So we have some rules that we need to go through and that will allow us to say, hey, these two triangles are congruent. So the first rule is SSS is a shortcut for side, 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 which means that this side, if it matches up with this side, if those two are congruent, and if another side is congruent to the same corresponding side of another triangle, and if the third side is congruent to the other one, if all three sides of triangle A is congruent to the same three sides of triangle B, then the two triangles are congruent, and the rule would be side, side, side. Okay? Now, if you have an angle in between two sides, so this is the minimum amount of information that you need to show that two triangles are congruent. So if we have a side, for example, like maybe this side, and matches up with this one, and if those are two are congruent, and the angle in between them, in between two sides, so I have two sides, angle in between, match up with two sides and angle in between. If this is the case, then side, angle, side is our rule. Okay? So all three sides, side, side, side. An angle in between two sides, side, angle, side. Okay? Now we also have another one called angle, side, angle. So that would be the side, look at how it's written, angle, side, angle, so the side is in between two angles. So I have an angle, maybe a side right here, and then another angle. And so I have angle, side, angle. Okay? That's what angle, side, angle would look like. And it has to match up from one triangle to the next. And then angle, angle, side. So this is just two angles and any random side. So it's different than the one right here, angle, side, angle. This is two angles and a side. Yes, so technically this is angle, angle, side, but the side is in between the two angles, so we call this one angle, side, angle. So this one is two angles, so let's go here and here. Two angles and a random side, so let's go like here. And the side is not in between them, it's just, doesn't have anything to do with the two angles, so it's just two angles and a side, so angle, angle, side. Now this last one, there's some very specific reasons that we talk about hypotenuse leg. Or specific rules that go along with this one. So number one, it has to, oh, Moses. All right, let's see, here we are. So it has to be a right triangle, okay? So it has to be a right triangle. So we have the right angle. Okay, so you have to know those two are right triangles. And in order for those to be right triangles, or the thing about right triangles is that you have this longest side, like opposite the 90-degree angle. This is called the hypotenuse. Okay, this is the hypotenuse. So the other two sides are called legs. So this is a leg, this is a leg. So we got legs and a hypotenuse. So a hypotenuse leg means that you have one side, one of the legs, so let's just say like this one, and the hypotenuse, okay, and it must be a right angle, because this is two sides and an angle. So we don't do side, side, angle, or angle, side, side. Okay, we don't use that. That's not a rule, okay? Unless it's a 90-degree angle and one of those sides is the hypotenuse. Okay, if you had the other side, this would be angle, side, angle. If the other legs were congruent, it would be something like, angle, side, angle, even though it's 90 degrees. So not every right triangle is going to be hypotenuse leg, okay? So you have to make sure that you have the hypotenuse and one other side, and it's a 90-degree angle for it to be a hypotenuse leg. Okay. All right, so as we're going through some of this, here are some reasons that sides can be congruent. Okay, number one, they could be given to you in a given statement. Number two, you could have a midpoint. If you have a midpoint, then you know that's in the middle of a line, so you're going to have two congruent segments, which then would be possibly congruent sides of triangles. The reflexive property is something that's congruent to itself. So if you have maybe like something like this, and you have two triangles, okay, this side right here is congruent to itself. So that works in both triangles. Okay, reason angles are congruent could be given to you. So a lot of the other information that we've had before, like vertical angles. Now, if you have parallel lines, then you have plenty of congruent angles. You have alternate interior, alternate exterior, corresponding angles. If you have an angle bisector, that's going to create two congruent angles. Okay, so this is just kind of a piece of note here that you can look back to and say, oh, what do I have? Do I have this? Do I have congruent angles? Well, does it come from some of this right here? Okay. Let's go to some examples, hopefully. All right, let's see. Let's see what we can do here. We'll do one at a time maybe and make it bigger. Might be a little easier to see. Okay, so it says, for each pair of triangles, A, are they congruent? So this is a yes or a no. And then we're going to write the statement in the correct order of letters. And then in C, we're going to give the reason. Side, 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 angle, side, angle, angle, side, hypotenuse, leg, one of those. Okay, so we have to go through, look at the figure, find anything congruent that we can figure out, and then decide whether the triangles are congruent, or if there's not enough information, then maybe there aren't congruent, or we just can't, we wouldn't be able to determine that. Okay, so let's see here. Let's find a couple of triangles that we think are congruent. I've got an angle K, here with angle M. If we're looking at JMK, I'm looking at that one, and LKM, so I'm looking at those two triangles. Now, if you need to redraw them, that might be helpful as well. Maybe you just redraw them. And you have angle there, and you have a side. Okay, so what do we need? Well, if I had another side right here, it would be side, angle, side. If I had another angle, it would be angle, angle, side. So can I find a side or an angle? Well, looking at the way the figure is, MK is in both triangles. So MK would be congruent to itself. So that's just another piece, that's a piece of information we'd have to come up with on our own by looking at the figure, and we say, oh, MK is congruent to itself, so that means we have side, angle, side. So we're going to say yes. Let's write the triangle congruent statement. So let's say JMK. If I say JMK to begin with, then I have to say LKM for the other one. Now, if I would have done it a different way, maybe I went JKM or KMJ, whatever. If I went JKM, then I would have to have gone LMK, just to make sure that it's written in the right order. And what rule did we figure out? That was side, angle, side. All right. So next example. Let's see. Are the triangles congruent? Statement and what reason? So I have right triangles, so my first inkling is hypotenuse leg because it's a right triangle. But AB is the hypotenuse and CD is the hypotenuse. I don't see those congruent. The lines are not parallel. It doesn't tell me I have parallel lines. If I had parallel lines, then it would be marked or told to me. But what I do have is a right angle, so I know those angles are congruent. So I have this one. I'll write ABC here, and I'll just draw the other one. So if that's A, B, and C, then this one would have to be D, C, B. So if I went from A to B to C, then I have to go from D to B to C. Wait. A to B to C, no, D to C to B. Yeah, D to C to B. Yeah, okay. All right, we're good. So AC matches with BD. I have the right angles. Okay, so I need, if I have this side, I'd have side angle side. If I had another angle, I'd have angle angle side, or depending on the angle, maybe angle side angle. So what about angles? I don't have anything with those angles. These angles, I'm not sure. I don't know if I have parallel lines. This side right here is in both triangles. So that side, BC, BC and CB, depending on which triangle you're in, is congruent to itself. So that's called the reflexive property. It's congruent to itself. So now I have, even though it's a right angle, I have side angle side. It's not hypotenuse leg because I don't have the hypotenuse. So let's say yes. Let's write the triangle name, ABC. That would be then DCB. And the reason we had was side angle side. Okay. Okay, next example. So it says that E is the midpoint of AB. So if E is the midpoint of AB, I'm going to go ahead and mark on my figure what I know. So I know that this is congruent to this, if E is the midpoint. And it's also the midpoint of CD, so I'm going to mark that as well. All right, so I have two sides. Can I find an angle anywhere, or the other side? It doesn't tell me I have parallel lines, so I can't use that. This angle right here and this angle right there, they're vertical angles. So they are congruent, and they're in between the two sides. So this is side angle side. So it'd be yes, and let's write down the triangle congruent statement. So I'm going to say, let's go ACE. So ACE, and then that would have to be A to C is down that blank one, so B to D to E. Okay. Let's see. Next example, what can we notice on this one? If we've recognized a few things, you can see, well, this side's congruent to itself. It's in both triangles. So 3 sides, side, side, side. And so this would be yes, they are congruent. And let's see, let's pick one, DAC. So if we go DAC, then we'd have to go from D to A, we'd have to go from B to C to A. Okay, let's see here. All right, next one. What do we know? Oh, we have parallel lines. They're marked. Great. So we can find some congruent angles. So let's see. If this and this are parallel, this would be maybe a transversal that went through them. I could say, oh, this angle would be congruent to this angle because they're corresponding. The L part of this triangle, then N. So I have an angle. Oh, that angle is between those two sides. So that's side angle side. Great. So that's a yes. Now let's name them. So if I go KJ, or let's go KLJ, That's probably easiest. KLJ, I don't know if it's easiest. KLJ, so this one would have to be MNL. All right, let's look again. What do we notice? I can see vertical angles, so I'm going to mark the vertical angles. I don't know if I need them or not, but I have an angle and two sides, so if I had another angle, then I could do angle, angle, side. I have parallel lines, so that means these would be alternate interior. Okay, I have two angles and a side. I could say angle, angle, side. Also, if you want to keep going, just to name all the congruencies, if these two are parallel, these two angles would also be congruent. They're also alternate interior. So we have angle, angle, side. We could have side, angle, side. Angle, angle, angle is not a rule, okay? Angle, angle, angle is not a rule. You have to have at least one side. So you pick your rule. I'll pick angle, angle, side. We could also say side, angle, side. And sure, angle, side, angle. There are three options there, so this is a yes. Now let's name it correctly. So if we go DAJ for the first one, you can go any way you want. That's just what I chose. So if I go DAJ, then that means I have to go EAM. Let's see if I can get that in there. Okay. I think we got it there. All right, last two. What do we notice here? Oh, there's no shared sides. I don't have any parallel lines. I have two sides and an angle. That angle is not between the two sides. I can't find a way to name congruent angles. Okay. So looks like this will not be congruent, because I do not have a way to find another angle. I would have needed it to be given to me. I would need a bisector. I would need parallel lines. I would need something else. So that was not gonna fly. So those two triangles can just weep and wail because they're not congruent. All right, and remember, side, side angle. Side, side angle. I say side, side angle because I don't want to swear. Is not a reason. Not a reason. Okay? So if you got to swear with your three letters, then it's not a reason. All right. And last example, we have FH bisects EH, so EHG, so EHG. So that means that this angle would be congruent to that angle. We got a bisector. Okay, so the definition of a bisector tells me these two angles are the same. And it also says it bisects EFG. So those two would be the same. Now what else can you see that might be congruent? Can we find another side? We don't need another angle because angle, angle, angle is not a rule. Can we find a side? Since the figures are together somewhat, we always look for shared sides. So this one is shared, so that could be your side. So it looks like we have an angle, side, angle situation. Yes, this also could be angle, angle, side, but since the side is in between the two angles, we say angle, angle, side. Or sorry, angle, side, angle. All right, so let's say yes, and let's name it EFH. We'll go EFH, so that means we'd have to go GFH for the other one. Make sure those match up. Okay, let's see what we have here. We might have assignment time. Yay. Okay, so if you're looking at your assignment now, let's just kind of talk through some of these questions here. So on 16.2, so we're doing what we just barely did. So you need to find information from the figures, like vertical angles or shared sides, or if you have parallel lines. You got to find sides and angles and then find a reason that they would be congruent. Or if you cannot, absolutely not, find a reason. Some of these are kind of tricky, so you might think about, just don't just make a rash decision as whether they are or they aren't. And some of them may not be clear what angles or triangles you'd want to use. But like I said, I've got the answer key, so you can try them, check them, just like we would do in class. If there's a question, please let me help you. We'll figure out a way to take a picture of or do a video or another explanation of individual problems or whatever, whatever you would prefer, whatever we can work out. It's just trying to be helpful here. Let's see, 16 point. Okay, so next, after 16.2, we'll get into some proofs, but for now, you've got two sections here that you can work on. Now, all you need to do is if it's easiest, take a picture of your completed work and upload it back to Canvas to me. If Canvas isn't working, I'm assuming you could attach it to an email or some way, get me back so I can check your work. Now, I don't need it until, like when we take the test. But if you'd like to send me individual pieces, that's fine. Just, it'd probably be better to do it all at once at the end. But I'm fine with whatever works best for you. All right, until next.